Welcome back to KU Pulse, the podcast from Khalifa University. My name is Jade Sterling. I'm your host for today, joined by Professor Roberto Sabatini.
Good morning.
You head up the FALCON program here at Khalifa University, which addresses key challenges in sustainable aviation and advanced air mobility, correct?
Correct.
Can you start by just breaking that down for us?
Yes. So advanced air mobility is about implementing technical as well as operational measures to build a more sustainable aviation future. So this includes enhancement in power plant, advanced avionics technologies that support operations, but also all the infrastructure, including future airports, advances in air traffic management, that ultimately will enable more sustainable air transport operations. There is a growing importance for low altitude operations. So, and this is about advanced air mobility. Advanced air mobility is about the future of urban and regional transport, adding the third dimension. So, not replacing conventional form of transport, but effectively enhancing these with the third dimension and reducing both gaseous emissions and noise, right, which is a very important element of sustainability. When assessing sustainability, we really need to look at the problem holistically. So there are environmental aspects, social aspects, but also economical aspects that need to be addressed simultaneously, right? And this is what allows us to perform a full life cycle assessment, both for technologies again and operations.
So we're not just talking your commercial flights. I'm not just talking, I want to take a flight from Abu Dhabi, where we are, to somewhere in Europe, and we're going to look at the sustainability there. We're also talking air transport within the urban environment. I'm assuming air taxis, that kind of stuff?
Yes, correct. Significant and increasing, actually, demand for air taxis, but also air cargo, right? Transport of goods within the urban environments and regional, so city or intercity transportation is leading to significant developments both in manned and unmanned aerospace vehicles. New vehicles, all right? So we are dealing with vehicles that now implement hybrid electric, thrust vectoring kind of technologies. So very advanced kind of technologies that will progressively integrate with the current modes of transport. So the future is really multimodal. We're not going to have a single mode of transport like replacing them all. And I believe that urban and regional air mobility, so what we call collectively advanced air mobility, has huge promises in terms of enhancing the sustainability of our increasingly congested urban and also suburban environments.
I'm going to pick you up on the sustainability aspect in a second, because like you mentioned at the beginning, it incorporates more than just emissions into the atmosphere. That's a large part of it, but there's more to talk about there, so we will come back to that. But first, it's a very science fiction kind of idea, a very futuristic image of a city to think, okay, right, we're going to take all the cars off the ground, all the lorries, all the transport, all of the haulage capabilities, take them off the ground and stick them in the air. That is a very almost comical image. Is that really where we're heading? Is that actually the best solution for moving everything from people to goods that we need to within our cities?
It will happen. And so indeed, there are significant challenges there, right? So challenges that are not as much on the technology side. I would say the technology maturity is relatively high. So to give you an example, we're currently engaging with the industry partner to develop real flying platforms. And we are going from the lab to actual flight testing. So that is the brand of the FALCON program and what we are trying to achieve as a center. Now, in terms of what you were mentioning, the perceived challenges and the reality of this, we're certainly going to see that happening within the next few years, right? So this is, I would say, from an aerospace engineering perspective, relatively low-hanging fruit, right? So
Okay.
there's something ready with one caveat, one very important caveat, the regulations, right? So there is a need for substantial advancements in the policy frameworks, new standards that will have to support the design, development, test, evaluation, and operation of systems, which includes not just the vehicle, but also the airspace.
Yeah.
And so we are working on both dimensions at Falcon, developing new technologies for the vehicle, electric, hybrid electric propulsion system, innovative avionics, innovative human machine systems that effectively allow dealing with trusted automation and even trusted autonomy in certain conditions. But on the other side, really there is a need to also evolve the airspace with new kind of airspace structure.
Yeah.
You can think of that like airways in the sky, right?
Yeah,
So-
totally. Because you're not just replacing the roads on the ground, sticking them in the air, and then trusting everyone to just obey those rules. If there's going to be some kind of autonomy behind it, you're going to need all of the infrastructure set up that's got the flight paths, that's got the equivalent of airspace traffic lights, for example, roundabouts, all the rest of it. Someone has to build that infrastructure to support everything before we can get off the ground.
Exactly. And there are many proposals, right? So obviously with the increasing level of airspace density, it's called like more traffic in the air, new kind of more efficient airspace structure are emerging. So different proposals have been elaborated. And we recently actually published a paper on that where we propose a new airspace structure that matches the separation assurance and collision avoidance requirement for future platform. So effectively deals with the uncertainty around each track. We call them track, right, in terms of ATM jargon. So, and that kind of structure using AI implements high level of adaptability. So AI has a big promise in future aviation. So can learn from the environment. But the way we do it at Falcon is not just letting the AI learn from scratch, right? So it would be like having a newborn learning about the world. It would take years before has a decent map to even walk and perhaps run.
And I'm assuming you don't have too much training data for an AI as it is.
That's exactly it. So what we do, we use physics-based AI. So not machine learning, but not just machine learning, different kind of artificial intelligence techniques that have been developed by computer scientists for many years, and we're very grateful to them as engineers. We implement them. We actually take the very best that is available out there, using some kind of meta reasoning that also implement physics-based criteria, right? So aviation has been in the business for more than 100 years, right? So ignoring all that body of knowledge would be absurd. So what we do at Falcon, we develop new systems that capitalize on the huge knowledge base acquired over the years and effectively develop new AI-based intelligent and increasingly autonomous systems that deal with these opportunities. Again, not just at the vehicle level, but also at the airspace level. So we develop avionics systems, power plants, new systems on board, as well as systems on the ground, so air traffic management that deal with the management of trajectory and mission. In particular, a very important aspect here is the airspace structures, which are also dynamic in nature. This is obviously a huge paradigm shift. As you know, present-day ATM is based on voice communication between the pilot and the air traffic controller, and decisions that are made mostly tactically, right, regarding separation, assurance, and collision avoidance. All these will disappear. So there will be a higher and higher level of automation, and this might look scary, but in fact is safer in terms of technology and the advancement that we have experienced in recent years. We know that this is the path forward. But again, to implement that, we need new regulations, new standards to emerge. And as of today, AI, right, cannot be certified for introduction in avionics and air traffic management systems. So, but we are working with the industrial community, with the standardization bodies, the IEEE, RTCA, ICAO, so the global community devoted to these new standards, to actually advance and based also on the result of our research, and looping back and feeding further research in this domain.
I think an important point that you've raised about the safety of it is all of this relies a lot on trust. You've got to trust the computers, the AI, the machines, everything. So there must also be a fair amount of work going into the cyber physical security side of things.
That's an excellent question. Yes, you're absolutely right. Trust is essential. But before trust, a fundamental step is explainability.
Okay.
You cannot trust something you cannot explain. Let's put it that way. And so the black box effect associated with AI, right? So in the context of aviation, in particular avionics and air traffic management systems of the future, what we are working on is a framework that allow going from explainable AI to trusted AI and ultimately certifiable AI,
yep.
right? So once you get that kind of chain closed, effectively you have enabled the transformation both in terms of policy, regulation, standards, and ultimately, enabling real-time operations, because it's not just about introducing or developing new design standard. They are deeply rooted on the, perhaps you're aware of that, the probability of failure associated to a specific system. So in the context of aviation, that probability of failure cannot exceed in safety critical environments like urban environments, for example, cannot exceed 10 to the minus 9. And as of today, cannot be demonstrated that a human operator probability of failure is below that threshold. And so that obviously requires, if you want to introduce a higher and higher level of automation, that obviously requires transitioning to sort of AI assistance, both in the cockpit, the flight deck, and on the ground.
Okay.
So that is really essential. And that's what we are working on very, very actively in collaboration with the industrial community.
So tell me about some of those projects.
Well, we recently had a contract awarded from an original equipment manufacturer that is dealing with the urban and a vehicle that is used for urban air mobility and also implemented and utilized regional air mobility. For that vehicle, we developed the GNC, the guidance, navigation, and control systems, the sense and avoid, so the system that autonomously perform separation assurance and collision avoidance, not just with other flying platforms, but also with the urban environment, actual
because you don't want to be hitting a building as you're trying to get through it. Yeah, that makes sense.
Exactly.
Okay.
And on that, in that area, we actually had 2 additional grants from the government that support these, and from Khalifa University that support the transformation. And we're also developing new advanced form of human-machine interface and interactions. This is called the cognitive HMI square.
Okay.
Cognitive human-machine interface interaction. So these are adaptive forms of human-machine interface and interaction, where not just the display function, as already happened, change dynamically depending on the mission, success criteria, and the actual metrics, right, that are measured in real time, the success metrics, but also the command and control functions. So what I mean here is that there is a continuous modulation of the level of automation and the delegation of authority between the human and the machine in different contexts.
Okay, so I think I'd pictured that if we're going to go down this route, it would be almost entirely AI, almost entirely machine-driven. But you're saying that there's still going to be humans involved in the day-to-day operation.
Absolutely.
Okay.
And as I mentioned, it's very hard to demonstrate that the level of failure of a human does not exceed the threshold 10 to the minus 9. But at the same time, also machines have their bottlenecks, right? They have certain limitations. Okay. There are certain tasks that machines, where machines far exceed the capability of humans. I mentioned before the airspace management, the dynamic, something that a human operator cannot reliably do in real time. Strategically, yes, it's actually done, but in real time.
But surely in real time, you've got to hit a certain level of speed, and there's also going to be that element of doubt, whereas a computer can't doubt itself.
It's about the dynamics of the platform, but also the challenges associated with increased level of traffic. But there are tasks where humans the performance of human is far exceed that of machines, and this will always be the case. Right? So that's why the future of aviation and sustainable aviation and advanced air mobility is not replacing the human. It's enhancing the human. Let's put it that way, or not even supporting the human, but enhancing the human with decision support systems. You see, the word decision support here is key. That ultimately, both on board and on the ground, that ultimately allow maximizing the synergy between human and AI agents cooperating effectively to achieve specific goals. So again, here in ATM, the key goals are obvious, right? So you want to maintain certain separation minima and avoid collisions, right? That's the main task of ATM. Plus, obviously, trying to maximize efficiency and sustainability increasingly, right? In the defense context, there are other metrics, perhaps a bit more dynamic. So aviation also has this huge domain of defense, of aviation, drones, but not just that. The evolutions that are taking place, and in the defense domain, the synergy between conventionally piloted and autonomous agents is increasing. So there we have metrics that are measured in real time that are more complex and typically rely on like operations research, decades of research in this domain, so that we well-established body of knowledge. Now, the great opportunity here is that we can learn lessons from the defense context and bring them to the civil world for the benefit, or the greater benefit of humanity, to make aviation even more sustainable. And on the other side, like civil aviation has also moved big strides in certain directions that would benefit the context of defense. So there is this interesting dichotomy and synergy and opportunity that we are exploiting with the FALCON program, and again address challenges of future aviation 360 degree, particularly looking at sustainable development, but also increasing safety and efficiency of operation in all contexts. So defense is also an area where I think trusted autonomy and human-machine systems such as the CHMI square that I mentioned before really have a lot of promise.
You said sustainability, so we're going to bring it back to that. We've talked a lot about this being in a more local, more regional context. We're talking kind of closer to ground level. But I'm assuming everything that we've talked about here, everything that you're working on at FALCON, can also be extrapolated to conventional air travel, the kind of aviation that we think about when we think about aeroplanes. I'm talking your short haul, your long haul, the stuff that happens actually up in the clouds.
Yes, absolutely. So in what's happening in conventional aviation. So let's say in the conventional ATM domain. So from the floor of conventional ATM, so say above 3 kilometers from the ground, and up to 18 kilometers. So like flight level 600. That is the conventional,
the kind of band.
Conventional boundaries. But they change depending on the country, and there's a lot of effort, especially in the US, now in Europe also, to enable operation above flight level 600. So there are already several platforms operating there, military, but not just military. Right? But as we move forward, in the conventional ATM domain, there is also a significant transformation happening. So you know that nowadays, as of today, large commercial passenger aircraft are operated by two pilots. And so we are transitioning from two pilots to single pilot operated aircraft.
With the addition of an autopilot, or is it just one guy at the front?
Autopilot is already on board. And there are various forms of, flight control systems that are more or less automated, increasingly so. But this is still not, replacing one of the pilots on board.
Yeah.
The big shift is through the introduction of AI agents. So AI pilot assistant, effectively, that support the human pilot in all phases of flight, and is effectively an evolution of the concept that I mentioned before, but this time applied to conventional aviation. And so again, in this context, the technology maturity is very high. So there are already forms of AI that would clearly support the case, and they've been demonstrated by our research group and centers a year ago. But now the point is, again, the regulations.
Yeah.
Right? So the policies and regulation that will support the transformation. And there is a lot of work going on, not just in the research domain, but also from the industrial communities, to progressively enable these new forms of AI-based avionics system. But as I mentioned before, as of today, the standards do not enable the certification of AI. So, in other words, if an aircraft is not certifiable, it cannot be sold and operated in all classes.
I mean, for good reason.
Correct. So you cannot demonstrate a safety case, and that means it would have to operate in segregated airspace, which is what's happening with drones, right?
Yeah.
With remotely piloted aircraft systems or uncrewed aircraft systems. There are different names for that, but drones is what the public knows. So the same thing would be needed to enable unlimited access of drones to all classes of airspace, conventional and future.
I think for commercial aviation, there's got to be a social acceptability issue as well there. I mean, I thought the point of having two pilots was that you've got a fail safe. If anything happened to the one, there's another guy who can fly the plane, another woman, another person can fly the plane. But if you were trying to sell that to me as a customer, especially in an age where we're seeing all sorts of aviation disasters at the moment, like it's a bit of a scary time. If you're trying to then tell me I'm going to take one of them pilots out and I'm going to put an AI in its place and you're going to trust it, that's going to make me a bit nervous.
Absolutely. I can understand you. But now I ask you a question. Would you be even more nervous if there was no pilot at all?
Yeah. I don't think I'd get on the plane.
Okay, then. So I think, it's part of the transition towards fully autonomous operation, in particular for passenger and most of the cargo transport missions. So that will be the long-term goal. Now, we got to be realistic about what, again, can be achieved in terms of technology maturity and, again, regulatory framework evolutions. So it will take some time until autonomous AI-based agents will progressively evolve to support this transformation. But this is a sort of inevitable trend. So the first step in conventional aviation would be single pilot operated aircraft, something that already happens, right? So so there are different kind of categories of aircraft, Part 25, Part 23, and so on. So some of these aircraft are already certifiable as single pilot operated aircraft, right? So say, for example, business jet, some of them can be operated that way. But, or military aircraft, right?
Yeah.
But in the context of civil aviation, there is obviously the social acceptance element as well. Important element of sustainability, and obviously we got to build a safety case. Until AI agents will not be certifiable in avionics systems, this simply will not happen. And what I mean by avionics system, by extension, I also include ATM, ground-based decision support systems. So, but it's a process that is already ongoing, and I have no doubts that within the next few years, substantial evolutions, substantial progress will be made that will ultimately allow the introduction of AI both in safety critical and mission critical applications.
The social side of it, just to pick up once more on that, it must feed into the sustainability aspect, because there's almost no point putting all of this effort into developing the systems, all that research, all that work to implement something that then is not accepted by the public, and then all of that stuff is just wasted. That is an aspect of sustainability, putting the effort into something that then operates for a long period of time, right?
Yes. Okay, so we're getting into sort of
I want to
business aspects.
Not necessarily. More about I'm trying to make the point that sustainability isn't just about trying to reduce emissions. It's not just about trying to prevent further damage to the planet. It's also about making things more efficient, making things last longer, making the whole life cycle of a project from initiation to actually implementation, making it worth the time.
Absolutely. No, I fully agree with this point. And in fact, at FALCON, we implement like a triple bottom line approach, which looks simultaneously at the environmental, social and economical implication. I think the business side should be also constantly looked at. Also because each dimension influences the other, right? So they're all interrelated. Sustainability is right in the middle, where you achieve an optimal balance. Social perception, we briefly touched this when we discussed about drones flying different airspaces or single pilot operations. Environmental enhancements are a natural consequence of optimized performance that are achieved through the design of more advanced kind of airframes, but also more advanced systems that support operations. On the business side, that is quite important. There are huge drivers there that also need to be taken into account. The aerospace and defense community, on a global level, is quite powerful. They have made massive contribution to the advancement of our society. This is undoubtful. Now, however, now we are at the point where if we leave the sustainability problem unattended, the environmental impact, and I'm just talking in terms of greenhouse gas emission and global warming associated to aviation, right? By 2050, it will be anything between 5 and 10% of global warming from a single sector.
Yeah, that's huge.
That's completely unacceptable. As of today, we have something in the order of 2.5-3%, right? So according to the literature. But again, if we don't continuously introduce new technologies and new operational paradigms, that's where we would end up. And so, again, the impacts and implications of increased global warming affect all society and have to be properly managed. Again, with a good balance between technology and actual operational paradigms, but I perceive that as an urgency that we have collectively, right? I understand the challenges. Obviously, aerospace manufacturers have been involved in conventional forms of flight. If you think about the first airliner, the first jet airliner, the Comet, right?
Yep.
Back in the 50s, and the most modern airliners today, I don't know, the Airbus 350 or Dreamliner 787, they got the same shape, right? And you may know that much more advanced forms of aircraft have been developed, like blended wing, box wing, flying wing, and implementing different forms of advanced aerodynamic configuration and distributed hybrid propulsion. So a lot of concepts have been studied and actually flight tested. So I would say that this demonstrated technology maturity, in some cases up to 6 or 7, but they have not come to fruition. The uptake of this sustainable aviation technology is relatively low. So obviously there are other drivers. And I would say many of these drivers are economical in nature. Obviously, we are a very safety cautious kind of environment, aviation, and it should be the case. Fortunately, our safety record is one of the best compared to other forms of transport, and we want to continue along this path. But ultimately, our goal within FALCON is, to design, test, and certify, right, systems that are safer, right, more efficient, right, for not just for environmental reason, but more efficient in terms of maximizing the profitability also of the business, and sustainable in the long term.
So we've talked about the low-level stuff. We've talked about the commercial range, the kind of the mid-tier stuff. But you mentioned there is airspace above was it flight 600, flight level 600, something like that? What's happening up there?
Excellent question. There is a lot going on above 18 kilometers, flight level 600, right, which is the current ceiling, right, of air transport operation. So in addition to military developments, so high speed, including supersonic and hypersonic aircraft of different kind, so exceeding Mach 5.
The Concorde of the past, that kind of stuff.
Yeah, Concorde was a supersonic aircraft, so not really hypersonic, but there are now a lot of platforms that are being developed, both supersonic and hypersonic aircraft, in endo-atmospheric flight. There are also increasing evolution for point-to-point suborbital transport and orbital, in fact, not just suborbital. So platforms that effectively are launched into space, stay into space for a short period of time, and then come back. I'm sure you're all familiar with, yes.
Okay, right. So rocket goes up, stays up in the air.
Yes.
The Earth moves underneath it, rocket comes back down again. That's what you're talking about. Basically.
In part, yeah, that's about the launch, yes. So probably you're referring here to, SpaceX and other endeavor. Yeah. There are other forms of, like commercial spaceflight that have been investigated and actually operated. Now, like Virgin Galactic use a slightly different concept. So it's horizontal, takeoff and landing kind of approach. SpaceX use a vertical kind of takeoff and horizontal landing. So it's a sort of hybrid, depending on, with the recovery of the first stage. So different concepts have been proposed, and actually some of them are already in operation. At the moment, they are proposed for like space tourism.
Yeah.
But there's more than that. So they can integrate with the high speed, high altitude operations. And I recently contributed to a task force of the American Institute of Aeronautics and Astronautics, specifically focusing on different technological and sustainability aspect of this new form of transport. And it was clear, absolutely clear, that point-to-point suborbital is growing and need to be considered. As of today, if you look at the whole pie of space flight, the human space flight, in particular this segment, only account for about 1.2 billion of the business, which seems a lot, but in a business that is, 100 times that, maybe it's not
it's
that
a little
much.
Drop. Yeah.
But it's certainly expected to grow significantly in the near future. And again, it will integrate sustainably, ideally, with conventional air transport, right? So including the other forms of transport like conventional aviation and also low altitude operation. Again, I'm absolutely convinced that the future is multimodal.
Yep.
So our airports, but even our cities will change, and we will have multimodal transport hubs where air, commercial spaceflight, but even urban mobility, not just air, because air mobility is excellent and there are many business cases for that, but there are still also conventional form of transport that will integrate. Again, I would expect that the solution that maximize efficiency, safety, and sustainability is multimodal. And, point-to-point commercial spaceflight, including both orbital and suborbital, is on the rise. So we will certainly hear more about that, as well as civil applications of supersonic and hypersonic, which you mentioned the Concorde, excellent program. In fact, several challenges associated with that form of transport at the time, right? So, but nowadays technology has made huge progress. So there are some aircraft that in fact reduce the sonic boom, one of the main problems, so the noise issue radically, right? And there are also very advanced technologies that have been experimented that would much enhance the passenger comfort, both for supersonic and potentially even for hypersonic flight. Indeed, the hypersonic flight represents a great challenge. As of today, this technology is mostly used for defense applications, but in the future, this show promises also for long-range air transport, both for passenger and cargo. Cargo, indeed.
The thing is, I can't not touch on this because I am all for spending more time actually on holiday than in the air trying to get there, okay? Like, absolutely, let's make more of the planet more accessible to more people, quicker, more efficiently. But I cannot understand how it can be more sustainable, because if you're going that high up, you must need so much more energy, therefore more fuel, different kinds of fuel. We're not just talking jet fuel, we're talking rocket fuel, surely, which must be so much more impactful on the planet than just like it sounds amazing to go up and come back down again and all of a sudden you've moved continents, but I just fail to see how that can possibly be more environmentally sustainable.
That's an excellent question, and in fact that's why within the task force of the AIAA we also had a special group focusing on sustainability. The technology development has to go hand in hand with environmental sustainability aspect. Okay, so like you mentioned rocket fuel. So liquid hydrogen and oxygen, let's put it that way, can produce a huge amount of thrust. Yep. And the byproduct is water. Would you know that? And so that would be fantastic, right? So instead of having all these polluting kind of molecules and aerosols in the air, we just have water, which, yes, has some greenhouse effect, but it's quickly absorbed by the environment. So unlike carbon dioxide that stay in the atmosphere for a century or more, water is quickly absorbed by the environment, right? However, the energy required to actually produce large quantities of hydrogen, liquid hydrogen, oxygen, and then store them.
Yeah, of course.
Require cryogenic temperature with huge impacts, not just in terms of vehicle design, but also in terms of the infrastructure that support that, also need to be considered. Right? So when looking at hydrogen has huge potential, and not just for high altitude operation, actually has potential in all forms of future aviation. Hydrogen in all its forms, so hydrogen fuel cells, but also liquid hydrogen, and increasingly like sustainable sort of liquid hydrogen in synergy with other sustainable aviation fuels. Again, there's no one size fits all, right? So the big promise of high speed, high altitude flight, including point-to-point orbital and suborbital flight, is that you can go from anywhere in the world, say from Abu Dhabi to New York in half an hour, right? So I know it sounds incredible, but that's pretty much, or maybe from Abu Dhabi to Sydney in 1 hour. It's feasible in terms of the opportunities enabled by that technology. So again, sustainability, as we mentioned, is not just about the environmental impact, although extremely important. It's also about the social and economical impacts that have to be addressed. Mm-hmm. And this is all part of the same transformation. So the multimodal kind of transport evolution that we will inevitably have to implement in the near future. The planet population is increasing steadily. Our cities and even what we used to call suburban environments are increasingly congested. And obviously there is a need to accelerate the business as well, right? So like certainly high speed is a great promise for people that cannot possibly tolerate. Like I'm from Australia, and it took me like take or give between 25 and 30 hours to get anywhere, like for example to Paris or Rome, including layovers and so on. So this, if the dream of cutting that time to 1 hour is something that personally would make a big difference. But I think for the global community, this would also contribute in a way integrated with conventional form of transport to a more sustainable future. We should always remember that technology continuously advances. Mm-hmm. So as of today, you're right, the propulsive element is one of the challenges, but propulsion technology is evolving continuously, as much as advanced forms of energy management and energy storage, different technologies that are being developed and tested in labs, and very, very soon, I hope, in the air. So all these technologies will contribute to a more sustainable aviation future. Again, there's no one size fits all. We all know that present day operations are very limited and in many ways unsustainable, right? So the way to make future aviation sustainable requires, expanding operation to all classes of airspace, both present day airspace and future airspace, above flight level 600 as well, and below the floor or current ATM operations.
I love that. So thank you for all of the research that you guys are doing over at Falcon to make what is genuinely quite integral to modern life more sustainable, more efficient, and more effective. And most importantly, safer. So Professor Roberto, thank you so much for your time today.
Thank you. Thank you very much for having me.
If you enjoyed that conversation and you'd like to hear more on all the STEM projects we do at Khalifa University, please consider subscribing. You can find us on Spotify, SoundCloud, and our website.